Hello, Honors Chemistry students. This is Mr. Spurk, and this is your Chapter 7, Section 2 notes, Ionic bonds and ionic compounds. So ionic compounds are composed of cations and anions. And remember that cations are positive, anions are negative, and overall they are electrically neutral. So they combine and they balance each other out. An ionic bond is an electrostatic force that holds oppositely charged particles together. These are always bonds between a metal and a nonmetal. Remember that the left side of the periodic table are metals. They lose electrons and become positive, and the nonmetals, they gain electrons to become negative. And what happens is the metals transfer their valence electrons to the nonmetals. So when we say oxygen gains 2 electrons, well, where do those electrons come from? They come from the metal that the oxygen is bonding to. So there are 3 steps when we talk about the ionic bond formation. And you can see with the little GIF here to the right what's happening. So we see the formation of the cation first. So you can see sodium lose its electron, giving it to fluorine. Or if you think fluorine, remember, is very electronegative, which is the attraction for electrons. So fluorine is actually taking that electron from sodium. So now sodium is positive, fluorine is negative, and those two are now electrostatically attracted to one another, so they form an ionic bond. Now, a chemical formula, this shows the number of atoms of each element in the smallest representative unit of a substance. And we've discussed these before, right? H2O tells us that there's 2 hydrogens and 1 oxygen. So ionic compounds exist as collections of ions arranged in repeating patterns. So for example, sodium chloride. You can see here that the green spheres are the chlorine or the chloride ion, and the sodium ions are the purple. You can see here that this is 1 unit of sodium chloride. But then we see many units of sodium chloride, and they are arranged in a very specific pattern. And the way that they are arranged is, for sodium chloride, is this crystal structure of a cube. And that is why when we look at crystals of sodium chloride, they are cubic in shape. So the chemical formula of an ionic compound refers to a ratio known as a formula unit. A formula unit is the lowest whole number ratio of ions in an ionic compound. So for example, sodium chloride, the formula unit is NaCl, and this is a 1-to-1 ratio. 1 sodium for every 1 chlorine. So let's look at how these form. So we have sodium and fluorine. So again, sodium is going to give its electron to fluorine, or fluorine takes it from sodium, becoming negative. Sodium is positive, so we have Na plus with F minus. They can bond. And how do we balance out a +1 and a -1? They just balance out 1-to-1. So their formula unit is NaF. So notice how individually they are positive and negative, but when combined, it is overall neutral. Magnesium and bromine is another good one to look at. So we can do this a few different ways. We can look at their charge. We know that magnesium is a 2+, and bromine is a 1- because it's in group 7. So if you think, how do we get these to balance out? Well, we must need another bromine. 2 bromines gives us overall -2. 1 magnesium gives us overall +2. Together, these balance out, giving us MgBr2. There's another way that we can look at it, and we can look at their Bohr diagrams here to the right. You see there how the magnesium loses its electrons to a bromine here and a bromine there. Another way we can look at this is magnesium, we know, has 2 valence electrons. We look at their Lewis dot structures. Bromine has 7. So what we look at here is this bromine is going to take this electron to get 8, And magnesium still has another one, so again we must need another bromine. And here we have this bromine taking that electron. And again, this tells us that our ratio is 1 to 2, MgBr2. Let's look at aluminum and oxygen. So aluminum has 3 valence electrons, 1, 2, 3. Oxygen has 6. So we can start to match these up. So this is going to go here. This one's going to go here. So oxygen can have 8. But you see aluminum still has another valence electron. So this isn't electrically neutral or balanced out. So we must need another oxygen. Again with 6. So aluminum's going to give its other valence electron here. But notice we still have this unpaired electron down here. And electrons don't like to be alone. So we must need another aluminum. So then we balance these out, bring this over here. But now again, notice that the aluminum now has 2 extra valence electrons and no one to bond with. So we must need another oxygen. So now we have all of our electrons paired up. And this would give us a formula unit of Al2O3. Another way you can look at this is aluminum is in group 3 and loses its 3 valence electrons to be 3 plus. Oxygen is a 2 negative. So what is a least common multiple of 3 and 2? Hopefully you know that it is 6. So to get both of these up to 6, we would need 2 aluminums for an overall plus 6. And we would need 3 oxygens or oxides to get us, negative 6. And again, that gives us an overall of Al2O3. All right, so let's talk about properties of ionic compounds. Most ionic compounds are crystalline solids arranged in repeating 3D patterns called crystal lattices. So sort of like we saw with the sodium chloride, we had NaCl repeating itself, forming that cubic shape. So crystals can take lots of different shapes and forms. So each ion is attracted strongly to each of its neighbors, and the repulsions are minimized. The large attractive forces result in a very stable structure. This is why crystals are some of the strongest objects we have or that we know of. So here are a few different examples, and you see some of them have differing colors. So a unit cell is the simplest repeating unit of a crystal lattice, and a coordination number of an ion is the number of ions of opposite charge that surround the ion in a crystal. So in NaCl, so if you look here at the NaCl diagram, let's look at the sodium here in the middle. So this is one unit cell. So in NaCl, each ion has a coordination number of 6. One sodium ion is surrounded by 6 chlorines. So if we look here, we have our 1 sodium, and it's touching 1, 2, 3, 4, 5, 6 chlorines. And if we were to keep building this structure, the chlorine would be touching 6 sodium ions. And we will look at better graphics of this, as you can see here with the link, in class. So there are different types of crystals. So in cesium chloride, each ion has a coordination number of 8. So again, we have our cesium ion here, and it's touching 1, 2, 3, 4, 5, 6, 7, 8 chlorides. So its coordination number is 8. In titanium dioxide, we see a tetragonal shape. And so coordination number for the titanium ion is 1, 2, 3, 4, 5, 6. And the coordination number for oxygen is 3. So if you look at the red spheres, they are touching 3. All right, so more properties of ionic compounds. They are hard, brittle, rigid solids because of their strong attractive forces holding the ions into place. And they tend to break around the edges of the crystal, where those unit cells aren't complete. That's why crystals don't really crumble, they sort of shear off. They have very high melting points. They have very high boiling points, and this is because of their strong attractive forces. It requires a lot of energy to melt or boil them. They are very soluble in water. Think about salt being very soluble in water. And they conduct electricity in the molten state, which means we melted them, or in the aqueous state when they dissolve in water. And these are what we call electrolytes. And you hear the term electrolytes all the time. We talk about electrolytes a lot with drinks such as Gatorade. And these are solutions that can conduct an electrical charge. And we need electrolytes to survive. Really, if we boil it down, we only need salt and water to survive because our neurons are firing and we need that electrical charge to stay alive. So when dissolved in water, the positive and negative ions dissociate, which means that they separate from one another, allowing that free flow of a negative charge. And as you can see here, we'll dive into these YouTube videos tomorrow in class. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a great day.